In late October 2025, renowned theoretical physicist Dr. Michio Kaku made a statement during a televised interview that would go largely unnoticed by the public, but which would later resonate deeply within the scientific community. On Newsmax, Dr. Kaku, one of the most recognized and respected figures in theoretical physics, issued a cryptic warning. Watch for it. He was referring to the interstellar object 3I/Atlas, which was due to reach its perihelion, the closest point to the Sun, in just a few days, on October 30th, 2025. Kaku's caution was not one of mere curiosity. He was aware of a critical condition surrounding the object that could challenge fundamental principles of physics. He explained that if 3I/Atlas experienced an extra burst of energy, accelerating in a way that gravity alone could not explain, then the world would be facing a momentous revelation. The object might not be just another comet, but a visitor from another star system, perhaps even one that was intelligently controlled. At the time, the statement might have seemed dramatic, almost theatrical, given the speculative nature of the claim. However, it was coming from a scientist whose reputation for grounded and forward-thinking insights into the nature of the universe was well established. A month later, the truth of Dr. Kaku's words would come to light, much sooner than anticipated. By the end of November, data collected from NASA's Jet Propulsion Laboratory, JPL, and the Horizon system confirmed that 3I/Atlas had indeed exhibited a strange and unexplained acceleration. The object had received a measurable burst of non-gravitational force, an anomaly that could not be accounted for by traditional models of cometary behavior. For those who were paying attention, this was not just a scientific puzzle. It was the beginning of a mystery that could redefine humanity's understanding of space, physics, and perhaps even our place in the cosmos. Understanding the anomaly. The non-gravitational acceleration. The data from NASA's JPL system revealed an intriguing detail. 3I/Atlas experienced a non-gravitational acceleration of 1.6 times 10 to the power of -6 astronomical units per day squared, O/day, caret 2. On October 30th. To put this into perspective, this was a small but measurable acceleration, approximately 0.05 millimeters per second per day. While such a small deviation may seem insignificant, over the course of time, it accumulated to cause a substantial shift in the object's trajectory. By November 24th, the acceleration had decreased to 4 times 10 to the power of -7 O/day, caret 2. But the presence of the anomalous force was undeniable. This deviation was significant enough that traditional models of cometary motion could no longer fully explain the behavior of 3I/Atlas. In standard cometary models, non-gravitational acceleration is typically attributed to the outgassing of volatiles, such as water and carbon dioxide, that are sublimated by the sun's heat. As these materials vaporize, they create jets that exert a recoil force on the comet, pushing it in a new direction. This process can explain some of the acceleration observed in comets, but the scale of the anomaly in 3I/Atlas could not be accounted for by these conventional explanations. The magnitude and duration of the acceleration, which deviated from the expected path by a significant amount, forced JPL to revise its trajectory models multiple times. The unexplained nature of this burst of energy was hard to ignore. This was not the first time such a phenomenon had been observed. Similar anomalies were seen in the case of Oumuamua, an interstellar object that passed through the solar system in 2017. In the case of Oumuamua, scientists also detected unexplained deviations in its trajectory that could not be fully explained by gravitational forces or known natural phenomena. These observations led to speculations that Oumuamua might be an artificial object, possibly a light sail or another form of engineered structure. Now, with 3I/Atlas showing similar behavior, the question arose again. Could we be witnessing the arrival of an object that is not just a random comet, but one that has been intentionally directed? Dr. Avi Loeb's analysis. The possibility of intelligent control as the scientific community grappled with the implications of the unexpected acceleration of 3I/Atlas. One scientist was ready to step forward and take the anomaly seriously. Dr. Avi Loeb, a Harvard astronomer and author of the widely read book Extraterrestrial, had long been a vocal proponent of the idea that some interstellar objects might not be natural, but could instead be artificial probes or spacecraft. Loeb's theories about Oumuamua, which he argued might be a solar sail or some other form of intentional structure, had sparked widespread debate. Now, with the data on 3I/Atlas in hand, Loeb was once again making a compelling case for the possibility that humanity might be witnessing an object of extraterrestrial origin. Loeb's analysis of the 3I/Atlas anomaly was methodical and grounded in the available data. He pointed out that traditional cometary models failed to account for several key aspects of the object's behavior. The non-gravitational acceleration was one such factor, but Loeb also highlighted issues with the object's brightness surge near perihelion. According to the standard models, comets should display a steady and predictable pattern of brightness changes as they approach the Sun. Yet, 3I/Atlas exhibited a sharp, unexpected increase in brightness as it neared its closest approach to the Sun, a behavior that could not be explained by the outgassing of volatile materials alone. Loeb also noted that the mass loss rate of 3I/Atlas was inconsistent with what was expected from a typical comet. Based on its observed trajectory and brightness, the object appeared to be losing mass at an unusually high rate, a pattern that did not align with the sublimation of ice and dust that typically drives cometary activity. These discrepancies led Loeb to suggest that the object's motion might be influenced by factors beyond simple gravitational interactions, such as propulsion from an external source. His hypothesis was that 3I/Atlas could be a deliberately engineered object, perhaps one that was deliberately oriented or even powered by unknown means. The implications of the data. A new era of exploration, the data surrounding 3I/Atlas presents a conundrum that the scientific community has yet to fully resolve. Dr. Kaku's prediction, initially met with skepticism, has now proven to be remarkably prescient. However, the implications of this data extend far beyond the realm of theoretical physics and astronomy. If the acceleration of 3I/Atlas is indeed due to factors other than gravitational forces or outgassing, then humanity may be confronted with the possibility that we are not alone in the universe. The idea that an object from another star system might be under intelligent control raises profound questions about the nature of extraterrestrial life, technology, and the future of human exploration. As Dr. Loeb and other scientists continue to examine the data and refine their models, we are entering a new era in the search for extraterrestrial intelligence. The study of interstellar objects like 3I/Atlas offers a unique opportunity to learn more about the nature of objects from outside our solar system, and perhaps about the possibility of intelligent life beyond Earth. The scientific community must now decide whether to embrace the possibility that these anomalies represent evidence of extraterrestrial civilizations, or whether there is another explanation yet to be discovered. Conclusion. The mystery of 3I/Atlas continues. The case of 3I/Atlas is far from settled. While the scientific community has largely avoided making definitive conclusions about the object's origin, the evidence continues to mount in favor of something unusual. Whether it is an artifact of natural cosmic processes or a deliberate creation from another civilization, the object's behavior has forced scientists to rethink their models of the cosmos. The warning issued by Dr. Kaku, once dismissed as speculative, now seems more significant than ever. As we await further observations and analysis, one thing is certain: the mystery of 3I/Atlas is just beginning. Whether this object is a cosmic curiosity or a harbinger of a new era in our understanding of the universe, it is clear that humanity's quest to understand the cosmos is far from over. The search for answers to the mystery of 3I/Atlas could unlock doors to a deeper understanding of the universe and our place within it.